Hi everyone, this is Abhishek Mathur, your physics faculty for JEE Mains at Altedemy. I hope you are doing really well. I hope you are doing really well and your preparation is going fantastic. I hope so. And to discuss a very important topic, we guys are here. We will be discussing Young's double slit experiment today. Please join fast, everyone. Please join fast. I request all of you to please join fast as soon as you guys can because we have to cover a very important topic today. All right. So I hope I'm audible to all of you. I hope I'm audible to all of you. You guys. Hi Kalpu. Hi. How are you, Kalpu? Kalpu, can you please rate the quality of broadcast? Am I audible to you? Am I audible to you? Am I clear, beta? Do reply in the chat box, Kalpu. Am I clear to you? I hope my video is clear to you. Please rate the quality of broadcast, Kalpu. Go ahead and type in the chat box from 1 to 10, for 10 being the best and 1 being the worst. Kalpu. Alright, so I hope your preparation is going amazing. Uh, Please do let me know how's your preparation going. 1 if it's not good, 2 if it's satisfactory, and 3 if it's going amazing. And I hope your preparation is going amazing. How's it? Kalpu, please reply. Tejas, hi Tejas. Please reply in the chat box. How's your preparation going? 1 if it's not going up to your expectation, 2 if it's satisfactory, 3 if it's amazing. 10. All right. Uh, Amazing, Tejas. It's good to know. It's good to know that your preparation is going amazing. All right. So, how are you all? Tejas, Kalpu. All right. So, Tejas is somewhat satisfied. Great. Great. All right. So, hi, this is me, Abhishek Mathur. I'm a pass out from DTU. I completed my mechanical engineering from there, and I've been teaching for nearly 4 years with a very renowned institute, and I have successfully guided more than 2.5 thousand students. And one thing which I absolutely love is engines and vehicles. See, when you are in mechanical engineering, now you have to study about a lot of engines, so that's quite obvious for me. All right, great. So, this is today's topic. We will be starting with the second part of wave optics. In the last part, we have discussed some basics of wave optics. We have discussed some basics of wave optics. We discussed interference and two extreme cases of interference, and those were destructive interference and constructive interference. All right, nice, sir. All right, great, great. So I hope you guys are thorough with what we have learned in the last lecture, and in today's lecture, we can proceed comfortably. All right, great, great. So if you guys remember, in the last class, we discussed a question. We discussed a question something like this. There were two sources. There were two sources, S1 and S2, separated by a distance of 3.2 lambda, and I asked you to find the number of maximas and minimas formed between S1 and S2, isn't it? Do you remember this question, everyone? Kalpu and Tejas, please reply. Please reply in the chat box. Do you remember this particular question which we discussed in the last lecture? Alright, so this question which we are about to discuss is somewhat similar. We have two sources here, beta. This is source 1. Just give me a minute. This is source 1. This is beta source 1 and this is source 2, and the separation between them is 3 lambda. All right. So in this question you are asked to find number of maxima and minima formed on this circular ring. On this circular ring, how many maximas and minimas are formed? This is something which we have to find out. All right. Great. So All right, so should we start with the question? Should we start with the question? There's one thing which I would like to remind you, that maxima is formed when path difference is n times lambda, and minima is formed when path difference is odd multiple of lambda by 2. I hope you guys remember these two conditions. We discussed these two conditions in our previous class. Great. So, see, if we talk about a point here, please pay attention everyone. If we talk about a point here, see, you will realize that a wave from source S2 will travel certain distance, and a wave from source S1 will also travel a certain distance, and the difference between them is going to be 3 lambda, isn't it? Difference between them is going to be 3 lambda. So is it an integral multiple of lambda? Is it an integral multiple of lambda? Yes. You know what does it mean? It means that we are going to obtain a maxima here. It means that we are going to obtain a maxima here. Please pay attention. We are going to obtain a maxima here. Why we will obtain a maxima here? Because delta x is going to be 3 lambda. Path difference is going to be 3 lambda, because the difference between the waves traveling from S1 and S2 is going to be 3 lambda. And similarly at this point, delta x is going to be what? Delta x going to be 3 lambda, because the distance traveled by S1 and S2 have a difference of 3 lambda. I hope this is clear to all of you. Pawan, hi Pawan. I hope you are doing well. Great. So we have two maxima. Here. We have two maxima here. Great. Now, if we look at a point where path difference is 0, at which position path difference will be 0? See, the distance traveled by wave from S1 and distance traveled by wave from S2 has to be same. So it is going to be at this equatorial point. All right, because this wave will travel this distance, and similarly this wave will also travel. These two sides are going to be equal at perpendicular bisector. All right, it means that path difference is going to be 0 here. It means that path difference is going to be 0. If path difference is 0, it means that the condition is of maxima will be formed here. All right, now please pay attention. If path difference is 0 here and path difference is 3 lambda here, so in between path difference must have been 2 lambda and lambda somewhere. If it is 0 here and 3 lambda here, it means that somewhere it must have been lambda and somewhere it must have been 2 lambda. Great. So we know that path difference here is going to be lambda, and path difference here is going to be 2 lambda. I hope this is clear to all of you. Path difference is going to be lambda and 2 lambda here. All right, and similarly path difference is going to be lambda here, and path difference is going to be 2 lambda here. This is something which we are discussing on the upper side, and similarly at the bottom, path difference here is going to be 0. Path difference is going to be 0. Path difference is going to be lambda somewhere here. In a similar fashion what we have discussed for the upper portion, path difference is going to be 2 lambda here. All right, killer star Karthik. Hi Karthik. Are you guys able to understand this? I hope you have seen my previous lecture. delta x is going to be lambda here, and delta x is going to be 2 lambda here. All right, great. So our question is nearly complete. Now, number of maximas. Number of maximas. Number of maximas. Please count. Please count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are having 12 maximas. We are having 12 maximas. We are having 12 maximas. And now we have to count the minimas. We have to count the minimas. Number of minimas. Number of minimas. Great. Can you try this on your own? I would like you to try it on your own. I'm giving you a few seconds to please count number of minimas on your own. Go ahead and count the number of minimas on your own. Please try it yourself, everyone. Please try it yourself. Okay. So I hope you guys have given it a sincere try. See, between 0 and lambda, path difference must have been 0.5 lambda. 0.5 lambda. And between lambda and 2 lambda, path difference must have been what? 1.5 lambda. And between 2 lambda and 3 lambda, it must have been what? 2.5 lambda. And in a similar fashion, we can say that between two maximas, there is one minima. This is going to be 2.5 lambda, 1.5 lambda, 0.5 lambda, 0.5 lambda, 1.5 lambda, 2.5 lambda, 2.5 lambda, 1.5 lambda, 0.5 lambda. Great. Now can you please go ahead and count? Can you please go ahead and count the number of minimas formed here? And please reply in the chat box, everyone. Please reply in the chat box how many minimas are formed here. Go ahead. Number of minimas. Number of minimas we have to find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 minimas. Great. Alright, so I hope this question is clear to all of you. Can you please reply in the chat box, everyone? Have you understood this question or not? Have you understood this question or not? Please reply in the chat box, everyone. Have you understood this question or not, everyone? Kalpu, great beta, your answer is correct, Kalpu. Others, please do reply. Tejas, have you understood this question? Great, great, amazing. Now, see, before starting Young's double slit experiment, there are a few things which we must know. First thing is coherent source. Two sources are said to be coherent if the phase difference between them is constant or zero. All right. Two sources are coherent if phase difference between them is constant. See, it does not has to be zero always. It has to be constant. All right. So this is something on which I would like to emphasize on. It should be constant. Delta phi should be constant. It can be zero. I mean, it can be zero for sure, but it has to be constant. All right. And frequency should be same. It means omega 1 should be equal to omega 2. All right. And there is one thing. Why do we need coherent sources? Why do we need coherent sources? See, the reason why we need coherent sources is that for sustained interference. We need them for sustained interference. For sustained interference, coherent sources are must. All right. If sources are not coherent, then you won't be able to see the interference pattern. All right. Now, all right, I have written this. Coherent sources are necessary for sustained interference. Also, two independent sources cannot be coherent. Two independent sources cannot be coherent. Thus, we use a parent source. Thus, 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 we use thus we use a parent source. Thus, we use a parent source. All right. So what parent source does is these two sources formed will depend on the parent source. All right. And because these two sources are dependent on one parent source, thus these two sources are not independent. They are dependent. All right. Great. Now, what are slits? What are slits? Let's see what are slits. If you have a paper like this, if you have a paper like this, if you have a paper like this, and now if you take a blade and simply cut a paper like this, these are your two slits. These are your two slits, and separation between them is small d, and these are your two slits beta. These are your slits, s1 and s2. S1 and S1 and S2 are two slits, right? S1 and S2 are two slits, and they they work as two coherent sources. They work as two coherent sources. All right. They work as two coherent sources. See, what happens is, what we will do now, we will place we will place a we will place a parent source here behind them. This is our parent source. This is our parent source. This is our parent source. See, this parent source is something which is going to illuminate slit s1 and s2, and then s1 and s2 are going to work as two coherent sources, and these two sources are not independent. Why? Because they are formed with the help of one single parent source. I hope this is clear to all of you. Tejas, Kalpu, is this clear to all of you? Please reply in the chat box. All right, all right. Now there's one approximation which we will be using. There's one approximation which we will be using in the Young's double slit experiment, and this is that for small angle, you might know this already, but just in case if you don't, for small angle, sine theta is approximately equal to tan theta, approximately equal to theta. All right, but theta should be in radian. Theta should be in radian. I'm writing it here. Theta in radian, not in degree. Please take a note of it. Theta in radian. Theta in radian, not in degree. All right, we cannot say that sine 1 equals to 1 if sine 1 is in degree. We can't say that. Theta has to be in radian. If theta is in radian, we can use this approximation. Sine theta equals to tan theta equals to theta, and it works perfectly fine. All right, great. So once more repeat. Kalpu, which part you want me to repeat? Kalpu, which part you want me to repeat? Please go ahead and type. Kalpu, type fast, please. Incoherent source, tell me about this. See, incoherent sources are those. All right, let me coherent source. All right, great. Just give me a minute. Just give me a see. Before starting Young's double slit experiment, let's discuss coherent source and incoherent source again. All right. Please pay attention, everyone. If this is a source and this is a source, this is source one and this is source two. And if there is a screen, if there is a screen, there is a screen, and take any point at random. Take any point at random. See, one wave is one wave is going from source 2 and one wave is going from source 1. When these waves meet, when these waves meet, what happens is its frequency is omega 1 and its frequency is omega 2, and they will change. They omega 1 omega 2 will change, will change continuously, continuously. Please pay attention, everyone. So if you remember it correctly, in a wave there must be a term omega 1t minus k x, and in the wave of second source the term will be omega 2t minus k x. So when these two waves, will travel, when these two waves will travel x1 and x2, when you will calculate the phase difference now, when you will calculate the phase difference point for point p, that delta phi will vary with time, will vary with time, with time. This delta phi at this point it will vary with time, it will not remain constant. See, even if this position is fixed, this position is fixed, so point is fixed, thus x1 and x2 are fixed, x1 and x2 are fixed, but omega 1 and omega 2 are not same. If omega 1 and omega 2 are not same and they will change with the passage of time, they will change with the passage of time, so delta phi is not going to be constant. If delta phi is not going to be constant, so at point p sometime it will be constructive interference, sometimes it will be destructive interference, or sometime it will be between destructive and constructive. So the interference at point p is varying continuously, interference at point p is varying continuously, so your eyes will not be able to perceive what is happening there. All right, you won't be able to see what is happening there. Things will change so fast that you won't be able to see the difference. See, this is what happens when we talk about lights around us, normal sources of light, your light bulb, tube light, CFL, LED bulb. We don't see interference because these sources are not coherent. Is this clear to all of you? Kalpu and Tejas, I hope you have understood this. Please do reply in the chat box. Please do reply in the chat box, beta. Is this clear to you? All right, so if we want to see a pattern, if we want to see a pattern, if we want to see constructive interference and destructive interference, if at a place constructive interference is happening and we want it to be constructive always so that we can see it and observe it, these sources must be coherent. All right, if at a point phase difference is something, then it has to be that particular value, it should not vary with time. If it will vary continuously, then we won't be able to see the effect of it. All right, now let's discuss Young's double slit experiment. So what happened in Young's double slit experiment was, please see, we had two slits, this is S1, this is S2, and the separation between these slits, is small d. The separation between the slits is small d, and there is a parent source, and there is a parent source behind, and this parent source is placed symmetrically. All right, parent source. Now from this parent source, light will go into source 1 and light will go into source 2. And we have a screen, we have a screen placed like this, we have a screen placed like this. The separation between screen and the slits is capital D. All right, this is our screen, this is our screen. Great, this is our screen. Now what will happen when light wave from S1 and S2, when light wave from S1 and S2 will meet at a point, will meet at a point. Let's see how this will work out. Let's see. If I take a point somewhere here, if I take a point somewhere here, right, if I take a point here, this is wave, this is wave from point, this is wave from source S1, and this is wave from source S2. They will meet at this point P, they will meet at this point P beta, they will meet at this point P. All right, now we have to see the path difference, we have to see the path difference. See, what happens is there is one assumption that small d is very less than capital D. Small d is very less than capital D. Thus 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 the angles formed are very small, the angles formed are very small. Thus the angles formed are very small. See, if beta this angle is theta, if this angle is theta, then this angle is also theta, this angle is also theta. And let me draw one perpendicular, let me draw one perpendicular from here, let me draw one perpendicular from here. If this angle is theta beta, then this angle is also theta. From geometry this angle is also theta. All right, and this is d. Then the path difference, the path difference delta x is going to be d sine theta. See, what we are doing now, what we are doing is this. Please have a look at this diagram, you will understand. Since the since the capital D, since the capital D is very large, since the capital D is very large compared to small d, the two waves can be considered nearly parallel. The two waves from S1 and S2 can be considered nearly parallel. All right, so how much distance the second wave covers more than the first wave, it can be found out by dropping a perpendicular, it can be found out by dropping a perpendicular. See, this is our path difference, this is our path difference, and this is something which we have found out from here. I hope this is clear to all of you beta. Tejas and Kalpu, please reply in the chat box. Is this clear to each and every one of you? This is our path difference. All right, this is our path difference. Delta x equals to d sine theta. Great. Now what we have to do is we have to use the approximation, we have to use the approximation. All right, we have to use the approximation. Using the approximation, using the approximation, using the approximation beta, delta x equals to d sine theta can be written as, it can be written as d tan theta. All right, this is something which we have discussed previously, that we have approximation and we have simply used it. All right, great. So what is path difference here? delta x equals to S2p minus S1, and this distance is y, this distance is y from center of screen, from center of screen, center of screen, from center of screen. from center of screen, this distance is y. All right, this distance is y from center of screen. So using tan theta, using tan theta beta, tan theta is going to be what? Tan theta is going to be, tan theta is going to be delta x equals to d tan theta, and tan theta is going to be y by d. What is tan theta? Tan theta is y by d. All right, see this diagram, because I have drawn this diagram in a compact space, that's why you might say that no, it is not, uh, tan theta is not equal to y by d. Let me take one another line, let me take one another line from here. Let me take one another line from here. Since the angles are small, if this angle is theta, if this angle is theta, this angle is also theta. Now from this triangle, please have a look at this triangle. From this triangle, from this triangle, we can say that, we can say that tan theta, we can say that tan theta equals to y by d. All right. Great. I hope you have understood this, everyone. Kalpu, have you understood this? Kalpu and Tejas, please reply. Have you understood this, everyone? Tan theta is y by d. Now what we have to do is we have to find the position of maximas and minimas. We have to find the location of maximas and minimas. I hope you guys remember, for maxima path difference has to be n times lambda, and for minima path difference has to be odd multiple of lambda by 2. Great, great. But before that, uh, can we have a look at central maxima? Central maxima. Central maxima. See what happens is, if we have a situation like this, and there is this screen, there is this screen. This is source 1, this is source 2. Right. So if I am considering a point, if I am considering a point right at the, right from the midpoint of the separation of slits. See, a wave coming from S1, a wave coming from S1 will travel this much, a wave coming from S2 will travel this much. These two sides will be equal. This is equal to this. All right. So at this point, delta x is 0. At this point, at center of screen, delta x equals to 0. So this position means that at center of screen, at center of screen, at center of screen, at center of screen, delta x equals to 0, and central maxima is formed. Maxima is formed. This is central maxima. Please remember, this is not the first maxima. The maxima formed at the very center of the screen is not called the first maxima. It is called as central maxima. It is called as central maxima. I hope this is clear to all of you. I hope this is clear to all of you. Great, great. So let's move forward. Let's move forward and locate the maximas. Locate the maximas. See, delta x equals to what? This is small d y by d. It should be equal to n times lambda. All right, it should be equal to n times lambda. This is your general formula. 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 Now let's talk about specifically first maxima. first maxima. For first maxima beta, for first maxima, dy by d, what should I take? For first maxima, should I take dy by d equals to 0 or lambda? Please reply in the chat box. Please reply in the chat box what should be the value of path difference for first maxima. For first maxima. Go ahead and type in the chat box, everyone. Please participate so that you can learn better. What should be the value of path difference for first maxima? Go ahead. 0. Kalpu is saying 0. No beta, it should not be 0 because path difference equal to 0 is the condition for central maxima. So for first maxima, path difference has to be what? Lambda. I hope this is clear. So position for first maxima is coming out to be lambda d by d. It is coming out to be lambda d by d. And in a similar way, can we find the position of second maxima? For second maxima, dy by d should be equal to 2 lambda. So y2 is going to be 2 lambda by d, 2 lambda d by d. Is this clear to everyone? Is this clear to everyone? Tejas, are you able to understand? Great. Now let's talk about one more thing which is known as fringe width. Fringe width. Let's talk about fringe width. What is fringe width? Fringe width. What is fringe width, everyone? See, fringe width is the width of the band. It is width of the band, and we will discuss in some time what is a band. Fringe width is the distance between two maximas or minimas. Yeah, what is this? Difference between two maximas or minimas. Difference between two maximas or minimas is fringe width, and from y2 and y1 you can. So an example of young students experiment in daily life. No beta. Kalpu, this is something which you won't see in daily life. Kalpu, this is something which will not be seen in your daily life. If you talk about interference is something which can be observed in daily life, but Young's double slit experiment is something which is not seen in daily life, because the apparatus which you are using, see, we have to use this apparatus. Young's double slit is not something which can be observed in daily life because we don't have this kind of apparatus in daily life. All right. And most importantly, you can't have two independent coherent sources. All right, if you have two independent sources, then you might obtain the result of Young's double slit experiment, but otherwise you can't. See, this is something which you will be learning in your college. When you will go to the college now, in the very first year of the college, you will be doing all these experiments in the subject known as applied physics. For first year, you will be studying physics in your college as well. All right. Irrespective of your branch in the college, you will be taught applied physics for 2 semesters in your first year, and there you will get a chance to perform all these experiments and how things work. Is this clear, Kalpu? Great. All right. So we have our y1 and y2. So we can find fringe width from here. It is sometimes written as beta. So beta can be obtained as y2 as y2 minus y1, and it is going to be lambda d by d. This is something which you should remember by heart. All right, the formula for fringe width is something which you should remember. It should be on your tips. All right, great. Tejas, Tejas, are you able to understand this? Tejas, do let me know. So this is the formula for fringe width, and uh, the location of maxima is given by this. All right. So if I write a general formula, if I write a general formula, a general formula, general formula, general formula for maxima, nth maxima. If I want to write a formula for nth maxima, it can be written as n times lambda d by d. It can be written as n times lambda d by d. All right. All right. I hope this is clear to each and every one of you. Please do reply in the chat box. Great. Tejas, are you there in the class? Tejas. All right. Let's move ahead. Let's move ahead. And this time we have to find the location of minima. We want where, at what positions on the screen we will get destructive interference. All right. Now we want to know the positions of destructive interference. We know that delta x equals to d tan theta equals to dy by d. Now for destructive interference it should be 2n plus 1 lambda by 2, isn't it? It should be 2n plus 1 lambda by 2. All right, 2n plus 1 lambda by 2 for what? For destructive interference. Now let's find first minima. First minima. For first minima, dy by d, it should be equal to lambda by 2. The first odd multiple of lambda by 2 is 1 into lambda by 2. All right. So from here you will get y1. Position of first minima is going to be lambda d by 2. I hope this is clear to all of you. And in a similar way, we can find the position of second minima. We can find the position of second minima. Great. For second minima, path difference beta, it should be odd multiple of lambda by 2, but which multiple? Third multiple. 3 times of lambda by 2. So from here you will obtain y2 as, it will be what? 3 lambda d by 2d. Got it? Now if I write general formula, general formula for nth minima, general formula for nth minima beta, it is going to be yn equals to yn is going to be what? See, if you will realize the pattern, the answer is coming out to be 2n plus 1 odd multiple of lambda d by 2d. See, this is first multiple of lambda d by 2d. This is third multiple of lambda d by 2d. And the other multiple is going to be 5, and then 7, and then 9. And this is how this pattern continues. Alright, I hope this is clear to all of you. I hope this is clear to each and every one of you. Alright. Now let's do one thing. Let's talk about the fringe width. what is a fringe? See, sometimes a fringe is also known as a band. If you will look here, you will realize sometimes a fringe is also known as a band. Now, what is this band? What is this band? This is something where some of the students might face some confusion. So let me emphasize on this. Let me emphasize on this. All right. See, what we have done so far now, what we have done is we have found out the position of maximas and the position of minimas. So when we are saying that this is the position of the maxima, what do we mean by that? We mean that at this particular point, at this value of y, the value of y which are calculated, at this value of y, at this point, what is this? This is a point. What is this? This is a point. So basically the positions which we are trying to find out, location of maximas and minimas, are simply representing a point. All right, and point is not a band. Point is not a band. Let me draw something to make you understand what a band is and what a fringe is. All right. So we will discuss this in a while. We will discuss this in a while. We are not discussing this right now. We are not discussing it right now. What I'm trying to discuss here is what is a fringe first, and then we will do this topic. Then we will do this topic. All right. Just give me a minute. Just give me a minute. So if this is our setup, this is our setup. These are two slits. These are two slits, everyone. This is S1, this is S2. And then we have a screen here. And then we have a screen here. And this is our central maxima. What is this? This is central maxima. This is central maxima. All right. This is our central maxima. Now please pay attention. Please pay attention. If you will go back, please notice one thing. Notice one thing. From the center, first minima will come first, and then we will have our first maxima. I hope you can see this because let me draw it. This is our first minima, and then this is our first maxima. Why so? Because it is 1 by 2 lambda d by d, lambda d by d, and this is lambda d by d. What is this? This is our first maxima. This is our first minima. I hope this is clear to all of you. And now we will have our second minima. We will have our second minima here. We will have our second minima here. See, the values of y which we have calculated before, what were those things? These were the values of the point where the constructive interference will happen, where the destructive interference will happen. Now let's talk about the band. Let's talk about the band or the fringe. All right, let's talk about the band or the fringe. See, between two minimas, between two minimas, we have bright band. So basically this is your bright band. This is your bright band. When we say that we have a bright band here, so basically what is a bright band? Bright band is something which is formed between two minimas. This is a bright band. This is a bright band. Right? This is a bright band. Let me use a different color. This is a bright band. Now, one thing which confuses some of the students is, in the bright band, can we say that there is constructive interference? No, beta. We can't say that, because in the bright band, there is only one point where the constructive interference is happening. There is only one point. There is only one point where the constructive interference is happening. See, the intensity will be maximum. The intensity will be maximum at the position where constructive interference is happening. And as we will go, uh, in this direction, the intensity is decreasing, and after decreasing, it will become minimum. All right. So a bright band is formed between two minimas. All right. And similarly, similarly, a dark band, a dark band, a dark band is formed. A dark band is formed between two maximas. Between two maximas. If you remember it correctly, now when we discussed interference, I told you that constructive interference and destructive interference are two extreme cases of interference. All right. There can be something in between constructive and destructive, because in constructive and destructive we have seen some particular values of phase difference and path difference. What will happen when phase difference is between that of constructive interference and destructive interference? All right. So that's the case. And uh, we will continue the lecture tomorrow. We will continue, a lot of things are left in this topic, and we will continue the topic. I'm sorry, this is, it should be dark. I have written something wrong. It should be dark. All right. So please, scan these QR codes and join our Telegram channel and Telegram chat, just in case if you have not, because we as teachers are available there and we are more than willing to help you to get your doubts resolved. All right. There are students who ask their doubts, and uh, all the teachers, they try to clear that doubt as soon as possible. So a lot of students are getting a lot of help from the faculties of Altedemy. So I would like to request all of you to please scan these QR codes and join our Telegram channel and chat, just in case if you have not done it already. All right. And please, please subscribe to our YouTube channel. We have a lot of free videos available. We are trying to provide the best quality content to all the students for free on our YouTube channel. Please join our YouTube channel, just in case if you have not already. And I do hope and believe that most of you have already joined the channel, but just in case if you have not, please join our channel. Please click that subscribe button and leave a like for all of us. And this is about our course. We have so many free videos available there, and our educational platform is so convenient. We have designed it, by watching the need of the students. What do students want from us? So please join our channel, and you will get an opportunity to learn from the experts from the various subjects, and that is something which is absolutely amazing. All right. All right, Tejas, thank you so much. We have amazing doubt solving sessions. You can get all your queries resolved by the teachers. We have amazing theory. We have absolutely amazing theory prepared by our experts. We give so much of time to prepare this theory so that you guys can get the best out of it. And the study material which will be provided to you is definitely amazing. It will really work for you. It can work wonders for you if you are a sincere student and if you are thoroughly connected with your teachers. and the webinar, the online webinar is absolutely worth it. Believe me, I hope you guys are enjoying the webinars which we guys are providing on YouTube, and I hope you can get a glimpse of how passionate we are as teachers to provide the quality content to you guys. And the questions, see, we believe that practice is something which is really very important in your preparation, and we guys work so hard to give you, a good amount of homework, quality questions which can improve your skills and speed. So please join us on our website altadmy.online. These are the various programs offered by us. We have three kind of programs, everyone. One is light, the other is smart, and the third one is proficient. The light program consists of interactive live classes, and structured courses and the various PDFs of the notes, and you guys will be having live test and physical notes. See, but my personal favorite program is Smart, because in Smart program you will get all the benefits of light program, but there will be certain very important things added. For example, you will get one-on-one mentorship. You can directly talk with your teachers and get all your queries resolved. And plus there will be mock test. All right, by giving mock test, what you can do is you can get to know the areas in which you are lacking, and you can work on those areas specifically. You can have a discussion with the mentors, with your teachers, that how you can improve, how you can work on the areas where you are lagging. All right, and just in case if you are still not satisfied, and if you want to be above all the other competitors, if you want to have an edge over all other students who are preparing for JEE mains, you can join our proficient exam, where you will be getting some extra amazing courses and extra amazing features. All right, so I hope you will join us, and I hope I will see you in your closed courses. All right, thank you so much. So that's it from my side. I'll see you in the next lecture of wave optics. All right, have a good day, everyone. See you in the next class. भाई दर्द हो गया मुंह में